Hey everyone, welcome to our lesson on translating the graphs of trigonometric functions. We're going to be talking about those sine, cosine, and tangent functions drawn out on the graph and what happens to the functions to make them move certain locations. So you can see the general formulas here for the sine, cosine, and tangent function, and you want to be on the lookout for numbers that have been added or taken away in certain places. All right, so if you see that you have a value in the place where we see h and k on any of these, that is going to cause a horizontal and vertical shift. Specifically, if you see a number in spot of h, that is a horizontal shift, so that's going to move it left or right. And if you see one where k is located, that's going to move your picture up or down. All right, so let's take a look at those shifts. More specifically, when we see that a number has been added on the inside where h is located, that's going to move left. Okay? When we see that it's been subtracted, that's actually going to shift it right. On the outside, if we see that it's been added where we see a k value, we're going to move our picture up, the whole thing, and if it's been subtracted, it's going to shift down. All right, a couple of other pieces that you might have seen in the past or you may not have are the numbers that were located next to the function, and those are going to cause stretches. Those are going to cause our amplitude to be in different locations. So I'm referring to this number here out front. If that is anything besides a 1 or no number at all, I need to look at that because that's how high my graph is going to reach and also how low it's going to reach on these trig functions. So I'm going to label it accordingly. So for this basic 3 sine theta, to get a general picture, I'll need to start by putting my 3 and -3 as the highest place it'll reach and the lowest place it'll dip down to. Center line, there's been no number added on the outside, so the center line is 0. Okay, we can look at it like 3 sine theta plus nothing, plus 0. And that number is our center line. Okay, and once you have those in place, you can draw in your sine curve. Remember, a sine curve is going to start at the origin, 0, 0, and move up from there. Okay, and then dip back down all the way down to the lowest part of the amplitude and finish one cycle back at 360 degrees. So if you want to see exactly where that's happening, you can label those degrees as well. So we've got 90 there, 180, 270, and 360. So what's going to happen on the general picture is we're going to reach our highest point at 90, meet back at the axis at 180, lowest point at 270, and meet back at 360. So it's finished one full cycle there. And it'll continue in the other direction. It's just a reoccurring picture of the same shape up and down, oscillating between 3 and -3 on this one. So I'll be down, up, reach its highest point, and back again. And it continues forever. All right, so how have the changes here on the bottom graph affected our picture that we see up top? Well, our number in front is the same. It's a 3, so that means the amplitude is 3. So we'll adjust that according to our center line. But we can see that I have theta minus 90 on the inside of the parentheses, which means a right hand shift. Okay, we're moving right 90 degrees. And plus 2 on the outside means I'm going to be moving up 2. Okay, so let's adjust our labelings for our axis here. So the new center line is 2. Since our amplitude is still 3, that means 3 up from that 2 puts us at 5. And 3 down from 2 puts us at -1. So we'll just adjust that. We can put in our same degree locations where they were before, and we'll just shift the curve, the actual picture. Okay, and you can continue these on the left-hand side if you like to as well, of the y-axis. All right, so if we have moved right 90 degrees, that means that our center point here, let's take a look at it. Our center point is now going to be over at 90 degrees. So we can start our picture there if that helps you draw it a little better. So we're going to start here. This is our sine curve. We're going to move up, meet back at the axis at 270 now, reach the lowest point at 360. And we didn't draw any more of the graph, so we don't have to continue in that direction. Okay, continuing left and up, and you can see that now it sort of looks like it has become a cosine curve, because we know cosine functions are the same picture as sine, but they are starting in a different location. They start at their highest point or their lowest point, depending on if they're positive or negative. So it looks to be a cosine curve, but it actually is just our sine curve that's been shifted right 90 degrees. All right? All right, let's take a look at a tangent function, which looks a little bit different from our sine and cosine curve. So again, we want to start by filling in our center line and amplitude. We do not have a center line that has been moved in the top function to tan theta, so it's still at 0, so we'll fill that in. Amplitude is 2, so that means the highest point it's going to reach is 2, lowest point is -2. Let's go ahead and fill in our degrees, 90, 180, 270, and 360. Those are the key locations. Okay? And tangent pictures have asymptotes at certain locations. If you don't remember where those are, you can type in to your calculator tangent of 90, tangent of 180, tangent of 270, and 360 just to let yourself remember where those are. And what's going to happen is on the locations of the asymptotes, it will say error because there is no part of the tangent function that exists there. Originally, they are at odd multiples of 90, okay? So 90 and 270, and then on the negative side as well. All right, so the tangent picture is going to sort of come up like so, and it's going to sort of right along the lines of the asymptotes, those boundaries, always approaching them but never quite touching them. Okay, so it looks something like that, and it just repeats itself on and on again, the same picture. So on our translated tangent function down here at the bottom, let's take a look at where it will be located. Amplitude is still 2, I can see, but my new center line is -1, because this number out here at the end means that we're moving down 1, so my new center line is -1. So let's adjust that first. If that's -1 and I'm supposed to have an amplitude of 2, that puts me at the top being a 1 and the bottom being a -3. I'm just adding 2 and taking away 2 to get those labelings. All right, and I can see that this function has also been shifted left. We have a number added inside. That means it's moving left 180 degrees. So let's label our degrees and see what the new picture looks like. 270 and 360. Okay. So when we shift 180 degrees left, that's going to put this location here, now at the middle. Okay? Now you can see what's going to happen, because if I shift each of these pieces over 180 degrees, so if I put that there, and I shift the one to the right over, and so on, it still looks like I have the same picture, and I do. It has been shifted, but since it was a full 180 degree shift, it's going to look like the same picture, since it repeats itself as a picture, the tangent function, over and over. All right, so this concludes our lesson on translating the graphs of trigonometric functions.